Failed scheduling. No nodes available to schedule pods 2 minutes ago.
If you don't want to make the same mistakes as me and go down this rabbit hole of KCNA learning and going through all the Kubernetes documentation and feeling entirely overwhelmed by all this terminology, and you want to actually get hands-on, deploy a cluster, start to tinker around, start to pull apart Kubernetes, then that's exactly what I'm going to show you in this video. So if you follow along the steps here, you'll end up with a simple cluster running on EKS in Amazon, managed by Terraform. Okay, so last year...
So previously I created a video about how Kubernetes was one of the goals for me in 2023, but I kind of failed at it. And so I watched the entire video from Lou, who works at GitPod, but I think I resonated with so many things that were mentioned in the video. And I've had these discussions with Lou. You know, we chatted about how I set up Minikube last year and somehow messed up the entire setup on one of these spare laptops that I have, right? And it was just not right way to learn Kubernetes, because the experience when you deploy containers to the cloud is kind of totally different. So I loved what he did with Terraform and AWS. I kind of was doing that same thing with AKS and Terraform. So AKS is Azure Kubernetes Service. In this video, I'm going to showcase that how you can deploy a minimal AKS cluster using Terraform, and hopefully it helps you with your learning journey with Kubernetes this year. And also, if you're new to Kubernetes, I did create a video which is basically all the prerequisites that you need before starting Kubernetes. So go check it out. So just to start, I'm here at Open Up the Clouds GitHub repository of Kate's starter EKS Terraform, the one that Lou was talking about. And basically the purpose of this repo is you deploy a very minimal EKS cluster, which is Elastic Kubernetes Service from AWS, and is using Terraform to deploy this, which I'm using too. Looks pretty straightforward, right? I'm gonna dive how you can do the same thing with AKS and Terraform. So I have my AKS repository here. It's called AKS-Terraform, and the link will be in the description. So what I've got is, your typical main.tf, outputs.tf, and variables.tf, which are the main ones, right? So let's go over main.tf. So nothing exciting in the first half of the file because it's all the providers that I'll be using. I guess it would be also nice to have this in the providers.tf, right? Anyways, let's go on to the actual Terraform code that deploys our AKS cluster. So we've got provider Azure RM, which we'll be using, and you can have your service principal set up here. I've commented it out because I use Azure CLI when I deploy an AKS cluster locally from my machine here. And then one of the providers that I'm using is called Random. And basically what it does is it generates or gives you a random prefix that you can utilize, because think of like storage account in Azure or even AWS. When you create an S3 bucket, remember how you need a unique name. So this helps with that. So what we are doing is in this block is creating an SSH key with a random prefix, right? Because we'll be using that SSH key. And same thing now with the resources within Azure, right? So I'm using that random library again to generate those prefixes for the resource group, for the AKS cluster, and other required resources. Okay, so this is where we are creating the K8s cluster. So we have got our location, we've got the cluster, we've got the resource group name, and the prefix ID, which we generated right here, right? And we'll have the standard B2s as the VM size. So you can look into this more, right? I think the smallest ones are standard B1, but I picked standard B2s or B2S as our node pool VMs. So we are creating a node pool called agent pool, and the VM size, we're declaring it here. And then I'll go over the variables. So the node count is set to 3 by default, unless you specify it to be less or more. The admin username is var.username, which is Azure admin by default if you're using this repository out of the box. And then we are setting up the network profile. So let's go over variables.tf. So the resource group location by default is East US because that's the closest to me, right? And I already went over the node count and the username, right? So that is basically the Terraform itself. I didn't want to go ahead and code this in the video because one thing that I've found is none of you like that, or at least maybe some of you like it, but majority of you don't like it. You can have a different opinion, but that's what the metrics is. So I've already had this code here. I can demo this, but before that, let me show you the kind of the Terraform graph. So this command, if you run Terraform graph, it kind of tells you what all resources will be deployed and kind of the connection between them. So let's go back to main.tf. Let's run Terraform. I think I've already initiated the Terraform repository here. So what that does is it downloads all the providers that we require, right? And all the necessary state files are created. So I can just do plan first before we do apply. Gonna zoom in one level up. Now we wait for our Terraform plan to run. So there are 8 resources that will be added, 0 to change and 0 to destroy. So I can go ahead and do Terraform apply, and this will basically create all the resources that we have specified in main.tf. Enter yes. So while that happens, let me show you the README because I've tried to add as many details as possible to help you get started with this. So the requirements, if you want to follow along, is you need to have Terraform installed, you need to have Azure CLI, and kubectl. For getting started, you'll do AZ login to authenticate your CLI with your own Azure account. In my case, I've already done that. And then you can update the defaults in the variables.tf, or also you can specify with a flag when you run Terraform apply. Then you connect kubectl or kubectl to the deployed cluster. And that will be our next step once our apply is completed. Okay, so after nearly 3 minutes and 50 seconds, we have the apply complete. And I forgot to tell, there is an outputs.tf, right? So you get all of this information that is outputted about the resources that were generated. So the main one is the Kubernetes cluster name, which is cluster-amazed-tick. So if we go to our README here, you can see I have included the instructions to make the note of the Kubernetes cluster name, right? Because now we can use Azure CLI to get the credentials that are needed for our local kubectl to connect to this cluster in the cloud. And that's where kubeconfig comes, right? So what you can do is run this command. I'll just copy this, paste it here, and change the name of the cluster to whatever the cluster name we got in the outputs.tf, but also change the name of the resource group. In my case, it's RG Pretty Blowfish. Hit enter, and it should save the file in the default directory for kubeconfig, which is .cube/config. But if you want to save this file in some other directory, you can do that by following the next command where you specify the file with the specific location. So now I should be able to do kubectl get nodes, and you can see we have 3 nodes which are ready. Their age is 5 minutes and 50 seconds because that's when they were deployed. But I have an example app that you can deploy, which is basically an Nginx app. So that is stored in app.yaml. So this is what your YAML file looks like. So you basically define the deployment and then you specify the spec. In my case, I named it aks-sample-linux app, and the containers that I'm using is the Nginx container, and you can specify which image you're using. In this case, I'm using the public image available through Docker Hub, which is in the Nginx 1.24.0, and then you specify some limits to the resources and which port you should expose for this container, which is 80. And then we have the service here, so a load balancer, right? And we are using the TCP protocol with port 80, and the target port is also 80. So now if we do kubectl apply-f app.yaml, so it did create the deployment and the service. Now we just wait for that to be deployed, and we should be able to get the pods that are running in our cluster. And you can see there is the Nginx example deployment that is ready and running. So we can get that by the service name, which was AKS sample Linux service, to get our external IP for the load balancer. So if I copy this, go into my browser, we should get the homepage for the Nginx. And there we go. Welcome to Nginx. If you're seeing this page, the Nginx web server is successfully installed. So this is like the default page that you get when you install Nginx. So we have our app running. If you want to take it step further, you can modify the app.yaml to include more containers and kind of build like a 3-tier architecture using Kubernetes and AKS. But yeah, that is the project in a nutshell. I'm also going to clean up my resources. So what I'm going to do is Terraform destroy, which will basically delete everything that we just created. So the resource group, the Kubernetes cluster. And I would recommend that you do that too after you're done, learning and building things so that you don't incur any charges. But yeah, I wanted to showcase this kind of starter Terraform AKS thing that Lou built for AWS, but this is basically in Azure. So now if I enter yes, it will destroy all the resources that we just created, and I can show you what the repository is. So if you go to github.com/rishabkumar7/aks-terraform-starter, you'll be able to clone this, fork this, and then kind of launch a minimal cluster within AKS using Terraform. So I hope you take benefit of this resource. And if you are trying to explore Kubernetes this year, specifically within Azure, and I want to wish you luck on your journey. I'll keep posting more videos about Kubernetes as I'm learning it myself and getting better at it. But yeah, hope you enjoyed it. I'll see you in the next one. Peace.